All right, checking if the stream is online. Just give me a second.
Yep.
And still nothing, still nothing. Okay, we're online, we're live. All right, let's take a look at the assignment from the last class and let's see what we got so far. Assignment. Print numbers from 1 to 100 and say if the number is odd or even. Okay, let's break this down into different pieces. This one means do a loop, all right? And
Okay.
this one, and say if the number is odd or even, it says do a conditional, all right?
Okay.
That's what we were talking about. Let's try to break these things down like this, so next time you know what I'm talking about. Okay. I'm not sure if I told you before, but did you know that we have a special class teaching us how to translate those assignments from English to, for example, pseudo programming language? It's nothing like
No.
Java or nothing like any other programming language, but it's just some exercises to help you to break the problem into small pieces that can be translated into process to be put together as a program.
Good idea.
Yeah, yeah. It's actually it's something you learn at the university. So, and
Mm.
let's go. When the loop reaches 80. Okay, so we're talking about when the loop, of course, reaches 80. So this is another conditional. Another conditional. Okay? And
Okay.
in here we say the increment needs to go by 2. So affect the loop step. This is important, Red. Let's take a look in this, okay? So when you're
Okay.
having a while I higher or equals to 100, for example, um, I plus plus. This is a fully functional loop. All right?
Okay.
This is a fully functional loop. It won't do anything. It is just printing. Actually, not printing anything. It's just looping and incrementing the variable. So pretty much this is the whole everything you need to do on a loop. You need a conditional and you need a way to break the loop. We discussed that last class, right? Of
Yep.
course, we are still missing something in here, and that would be the initialization of the variable because while doesn't count with initializations, right?
Right.
Okay, so when I say this, when you're creating the breaking conditional and you're doing something like I plus plus, it's the same thing as saying I is equals to what was the value of the I at that iteration plus 1. That's what you're doing. Okay?
Okay. That's what I was doing, and I was obviously messing it up.
Okay. So that's what we're doing. So I plus plus just translates to I is equals to I, which means what was my value at that iteration, and add
Okay.
I add 1. Okay,
Okay.
so at the first iteration, what was the value of I? It was 0. Okay, so on I plus plus, which can be translated as this, it would be okay. 0 is equals to 0 plus 1.
One.
Then the result would be 1. And that
One.
value would be stored inside of the variable I. So in the next iteration, and when I'm talking about iteration, it's I'm talking about the every single step you take into the loop. Okay, when you say you need to take you need to do 10 iterations. It would be the same thing as doing as saying, okay, you need to repeat this loop 10 times. It's the same thing, okay? So iteration, not iteration. Iterations is when you're interacting with something. Okay,
Okay.
so when you have a button at your program, for example, and you need to click into that button, that means you're interacting with the button. Okay,
Right. Right.
but when you're iterating, it means you're taking one step at the loop.
Okay.
All right. Okay. So
Okay.
every single iteration, I'm adding a value into my I variable, and my I variable, of course, is the breaking condition of this loop. So since we are just adding one, and we are pretty sure that step, as we called, is 1. All right. So if you need to change that to step 2, you could just do something like I is equals to I plus 2.
Okay.
It would be, for example, at the first iteration, it would be 0 in here. So 0 equals to 0 plus 2. All right.
Okay.
So what's the value? 2. Next iteration, the first iteration, actually the second iteration will be 2 is equals to 2 plus 2. It would be 4. At the third iteration would be 4 is equals to 4 plus 2. It would go to 6, and so on and on and on. Okay. So that's this small thing in here. This small thing in here that controls the loop break, okay, the loop condition. It's called step. This is not as obvious at the while loops as it is for the for loops. On the for loops, we are going to see that more closely, okay? Even because especially, for example, when you're not doing, when you're not using step as a breaking condition, when you're using something totally different. For example, while the file is still being reading, or while the file is still being received, or while this file is still being processed, do this.
Okay.
So when you reach the end of the file, that would be the breaking condition of that loop.
Okay.
So as you can see, there's no step on that. Yeah, go ahead.
Okay. For the I equals 1 or I plus 1 is I plus plus, how would you change that to make it plus 2?
In some languages, you can add something like this. You can say I is equals. This is the same thing. This sign in here, Red. This sign in here is just the same thing as saying my value is equals to my value added to something.
Oh, okay.
Okay, so this plus equals stands to add my value to something.
Okay.
All right, let's take a look in Java if that's working, if that's possible. So I is equals to, or for example, let's say, there you go. Let's see, is there any problem? No, no reds, you see?
Yep. Okay.
So take my value and add to my value 2.
Okay.
Which is the exact same thing as saying I is equals I plus 2. It's the same thing, okay? There is a difference in here, and but this is something we need to discuss in the future, and it's not really relevant right now. It's not really important, but there's a difference between this and this. Okay. On this one, it means do the thing and add 1. And on this one, it would say add 1 and then do the thing. So don't worry about it. It will be more obvious in the future. Okay.
Okay.
And it's not something that. This is something we do when you need to optimize your code or to make sure that something it's running according to a specific rule or whatever. You don't really need to worry about this right now. Okay? So let's take a look at this. So first things first, do a loop, then do a conditional, and then do another conditional inside of the conditional. You see?
Okay.
So let's take a look at this. So do a loop. All right, you did it. And then you do a conditional. All right, you did it. And then you do in a condition again after that. All right, let's take a look if this is working. So Assigning a number to the variable. Int I equals to 1. All right, so right now you're not just assigning, you're declaring the variable and assigning the value. So that's what you're doing. Declaring and assigning.
Okay.
Because why are you declaring? Because you have the type in here and the variable name. That's why you're declaring the variable. If you're just assigning, it will be something like this.
Okay.
All right? Okay.
Mm-hmm.
So loop while the number is less than 100 and print the number. So let's see. Loop, okay, while, and here's your breaking condition. While I is lower or equals to 100, okay, all right. Print the number, excellent. And then you're just saying if, let's see, if I, which is the variable that controls the on which iteration am I right now, all right? If that variable is higher or equals to 50, change the step. That's what you're doing. I equals to I plus 2, which would be the same as saying I equals plus 2. Would be the same thing. I'm just showing this so you don't get confused when you see something like that on someone else's code, okay?
Okay.
All right. So actually, Red, the just as a curiosity, this small thing in here would run way faster than this one. Because this one is optimized. All right. But this is something like, okay, I need to scrub bytes and take every single inch of processing power I could get my hands on. Okay, it's not something that we would actually bother if you're writing a software that won't need that that will not have that amount of requirement on hardware or software. It's not something like, it's not a real-time operation. When we talk about real-time operations, for example, when you have a device that is attached to a patient to check his heart rate, or a device that will work with a radar and see if there's any airplanes on the way. Those are time-sensitive operation that's why we call them as real-time operation. Okay. So now this one, it doesn't really matter if you're showing the button 1 second earlier or 1 second after. It doesn't really matter. No one cares about that right now. Okay. You will start caring about that when you need to run a huge software into a less powerful machine. That's when you start worrying about. And usually you just say on your requirements to run the software, you need a big ass machine to run this. So if you can't afford that, it doesn't matter. You can't run my software. Okay, so you're changing the step in here. Excellent. And you're saying that when at the moment you reach something that's higher than 50, change the step. Start using this step. If not, use the same old step you have been using, which is I plus that can be translated to I equals to I plus 1. Excellent. And then you're doing the odd number. So let's see. And then you're saying if I mod 2 equals to 0, which means the rest, the leftover, what have we been calling it? It was
mod.
No,
average.
Yeah, no, not average. It was something like
the result.
No, not the result, because the result would be 2 divided by 1 would be 2. 2 would be the result, and 0 would be not the rest, it would be the
remainder.
The
leftover.
Yeah, that's it. So the remainder. So I mod 2 equals to 0. If the remainder of this operation if the remainder of this operation is equals to 0, print this. If not, print this. Okay, let's give it a try, but I'm pretty sure your software is correct. Let's see. Well, as I can see in here, let me go all the way to the top. So 1, 2, 3, 4, excellent. It's running okay, and it's saying that if it is an odd number or an even number. So it is actually saying, let's go to the first one. 1. Is 1 an even number?
No, and it was
So
printing right.
yeah, so what's going on in here? Let's think about it. Let's think about it for a second.
So, and I tried doing it this way.
No. Don't change your code, because
Don't
your
change
code,
it. Okay.
yeah, your code is correct. The problem
Okay.
is with the flow. Okay? The problem is with your sequence. That's your problem.
Okay, so I should have the first print would be odd and then the second even?
No, because that would be wrong, actually. Why would be
Okay.
wrong? Because the reminder of this operation, if the reminder of this operation is
It's
0,
yep.
it is
It
even.
would.
So it's
Yep.
correct. So the problem in here, Red, the problem here is with your variable operation. That's the problem. That's the only problem you have right now. Okay?
Okay, so should I be 0?
No. Don't try to guess. When you have when you find yourself in a problem, when you find yourself into something that you can't explain, what do we do, Red?
Debug.
Debug. Excellent. So breakpoint at the variable declaration. Awesome. And let's debug that. All right. So F8 and put your mouse over the I. Let's see which is the value. Is 1. Awesome. F8. At the first iteration, what is the value of I?
1.
Okay. So you are printing the value F8. Take a look at the bottom at the output screen. You see? So it's printing 1. Excellent. So is 1 higher or equals to 50?
No.
No. Okay, F8. What are you doing right now?
Counting by ones.
Adding 1, actually, right?
Yep.
You're saying 1 is equals to 1 plus 1. That would be 2, all right?
Right.
So what is the value of I right now? What is the value of I?
2.
2. Excellent. So I mod 2. What is the remainder of 2 divided by 2? What is the remainder?
0.
0. So is that an even number? 2
No.
divided by 2 divided by 2.
Yeah.
Is it even?
Yeah.
So you see the problem?
No.
Let's do it again. F8. It's okay. Let's do it again. So what is the value right now? 2. Excellent. So F8. Print 2. Awesome. Is 2 higher than 50? No, it is not. So F2. What is the value of I right now?
Here?
Yeah, what is the
2.
value?
2.
Okay,
Okay, so it would be
press F8
4.
now and check again. What is the value?
Oh, now it's 3. Okay.
Okay, why? Why is it 3? It's because you did that increment operation. You just did that.
Right.
Okay, so when you did the increment operation, and then you're checking if the value of I is higher or actually if the remainder of I is equals to 0. That's what you're doing. So you think that you're checking for 2, but you're not checking for 2. What is the value of I?
3.
See, you think you're checking for 2 because right in here you're printing 2. You see?
Okay.
but you incremented that value in here. So it's no longer 2. You already printed that in here. All right?
Hmm.
Then you did your increment, and after you did that, then you went and check if it was odd or even. So at the beginning, you were checking for 2. Excellent. This 5, it was printed by me. Okay, so don't worry about it. So uh, you were checking for 2, and then you did an increment. So you give it another step and said, okay, now check if 3 divided by 2 has a reminder different from 0. That's what you're doing.
Okay.
Got it?
So,
Now, did you understand the problem?
yeah, but I'm not sure how to fix it.
No, it's okay. So just tell me
Okay.
if you understood the problem. The problem.
Yeah.
What was the problem then?
I'm looking for it to be a remainder of 0, dividing it by 2 when every time it adds 1, it's no longer 2.
Excellent.
It could be
That's the
3, 4, 5, 6.
excellent. So you're always checking one step after the one you were checking before. That's what you're doing.
Okay.
Got it?
Yep.
Okay. So the problem is, Red, you're checking this too late. Your variable value is already changed. That's the problem.
Oh, okay.
So you're printing in here, okay?
Hmm.
And then you're doing the variable change. So what do you need to do is, what do? We just move from down here to
Oh,
up here.
and
So
I had it up there to begin with.
print in here, check if it is odd or even, and only after that you deal with the step.
Okay.
Let's give it a
Okay.
try again. Playing, and let's see what was the result. Okay, 1 it's an odd number. Okay, 2 it's an even number. All right, and the rest is correct. Let's go all the way to the 50. To 50, there you go, 50. And at 50 it said, okay, it's an even number, and then it changed the step. It changed the step to 2. So it's going to be
Okay.
52. 52 is an even number, 54, and so on and on.
Okay.
Okay. So did you
Okay.
got that? Did you understood what was wrong with that?
Yep. Yep. Now I do.
Okay.
I
So
wasn't. I had it up there before, but then I couldn't make um the this part work the way I had it, and I must have did it 50 times, and I couldn't make it work. And then anyhow, so now, yeah, and after that I moved this down here, and I shouldn't have.
no, it's okay. But the main thing in here, Red, is just to understand what was wrong. Okay, and just to understand the sequence you need to follow, the sequence you need to obey. It's the same thing, Red, as you need to go. I want you to go to your bathroom. What do you do when you're going to your bathroom? Okay, you need to get up off the chair, walk all the way to the bathroom door, open the bathroom door, get inside, and close the door. That's what you need to do. Okay?
Hmm.
But if
Yep.
you're not following the steps correctly, you would end up with doing something like get up of your chair, go all the way to the bathroom, and close the door. You see, so it's
Yep.
really important for you to understand what are the steps you need to take. Okay, so every time you're thinking about programming, you're thinking about what are the steps I need to take to fix this problem or to
Yep.
solve this assignment. Okay.
Yep. And now that I'm looking at the assignment again, it's right here. This goes before this, and I didn't pay attention.
Yeah, but that was because we are trying to make those things easy because not always the assignment will come as clear as this one. Okay, Yeah,
Right, right.
yeah. Sometimes the customer is going to say, okay, I want something that will increment by one, but when if we yeah, if reaches to 50, then increment by two. Oh, and also print if it is odd or even.
Okay.
That's one way to put it. So you need to understand what was the problem. Forget about how the customer told you to fix that, and create a new way, or at least try to figure out how to solve that. All right.
Okay. Yep.
Okay. Let's just one more thing we need to discuss about whiles, and this is a huge thing because that's actually the main difference between the next loop I'm going to teach you. But while uh, what was the requirements for whiles? Well, okay, you need something. You need conditional to break the loop, and you need to make sure that the loop will be broken. Okay.
Okay.
And I just
Yep.
told you about this, and I told you that those were steps. Okay?
Hmm.
All right. This is completely true on the next kind of loop. That would be the for loop. On while, you won't have something like an increment to break the loop. As I told you before, sometimes it's not like, okay, when you're done doing this for 50 times, stop. Sometimes you don't have any idea when will this end, when will this be over. Okay,
Okay.
just a hint, Brad. When you need a software to run endlessly, when you need a software to run without a specific lifetime, you will be running inside of a loop, and you will be running inside of a while loop. Okay, that's what we call
Okay.
the main loop.
Okay.
So it doesn't matter. It doesn't really matter if you're running. Let me show you a good example in here. So let me open the notepad. Notepad. There we go. Okay. So as you can see, this is a software, obviously.
Hmm.
And in here, well, okay, I don't see any programming lines because this is a compiled software. And quick question, how does the software know that it is supposed to stop running? How does it know?
It has to have a breakpoint somewhere.
Yeah, but where? Where is the breakpoint? What is the breaking condition of that? So this,
For
yeah, go ahead.
Go ahead. I was going to say for this, it would be hitting the X or
Or
um, the exit. Yeah.
excellent. So the breaking point in here would be hitting the X or hitting the option exit. Excellent. So as you can see, this is not something like a step-based loop. For example, I equals to 0 while I is lower than 10,000, I plus plus. If this software was based on this kind of loop, for example, it would run 10,000 iterations, and then the software would be closed immediately.
Okay.
But there's no way of making sure how long the software is supposed to stay running.
Okay.
Maybe you started Notepad and went to on a vacation, and you didn't had a power outage at your home, and when you come back, the software is still running. It's still running. So this wouldn't work at all because on this kind of loop, it requires a step. It requires the breaking condition, and it requires the step to break that condition.
Okay.
And at the while loop, it gives you more flexibility. It just requires a Boolean condition in here. All right? But it
Okay.
lets you decide when to break this condition. It lets you to decide that.
Okay.
So the one thing you are going to see when you're talking about endless loop or main loops, for example, is that most of the main loop it's going to be something like this: while true, do this. And at some point, in your software, there will be a option that says if the user clicks on the X or on the file exit, break wow, break the main loop. That's what's going to happen. So it doesn't really matter what kind of software you're running. It doesn't matter if it is a game. It doesn't matter if it is a Windows software, it's a Linux software, it's a software that runs inside of your mobile. It doesn't really matter. If the software keeps running and running and running until you tell him to, until you tell it to stop, it has a while. Even if the programmer have no idea what's going on. Even if the programmer who wrote that software have no idea that there was a main loop. Somewhere, at some level, there's a main loop making sure that the software will keep running. Got it?
Okay.
So what is the difference between those two for now? The difference is on this one, at this one, you don't need to tell beforehand how long will this run. This is the difference.
Okay.
For example, while the file is not over downloading, keep running the download manager.
Okay.
What is the size of the file? I don't know. It might be 1 KB, it can be 1 gigabyte, I don't know. So this is what you use, okay?
Okay.
But for simple loops, I know that I need to take 10 steps to go all the way to the bathroom. So I don't need to do something like this. Can I do something like this? Yes, I could do something like while not in the bathroom, walk to the bathroom. This is in the event, for example, that I'm not sure where the bathroom is or how long would take me to go to the bathroom. But if I know how many steps, for example, I need to take to the bathroom, it would be something like take 5 steps. And after it took 5 steps, you're just going to say open the bathroom door. There you go. So it's going to be like it would be, just to make clear, more clear in here, it would be like step. All right? Step 1, step 2, step 3, step 4, step 5. Break the loop. Okay, open the bathroom door. This is the on the event that you know how many steps you need. Okay?
Okay.
Okay. All right. Okay, that leads us then to the next class. So closing this one. Have I told you that I hate the way you do this?
Yes, but you also told me that you liked that you were able to see what lesson we were on.
Yeah, but whatever. I like to contradict myself, so whatever. Lesson 4.
Nope, 5.
Yeah, just to make sure you're paying attention. Right. Okay, org.red, and let's discuss about okay, you see that I did a boo-boo in here. Lesson 4, and I said the package name was just org, and I said that class name was just red. So okay, let's keep this way, just as a reminder to always pay attention to what you're doing. Okay, how does this work? How does loop step-based loop work? So step-based loop for condition, for initialization, condition and step iterate. All right?
Okay.
So this is where we're talking about step-based loops. You need to have something that will store the amount of steps you already taken. Okay? You need a way to make sure that you need to break that loop,
Okay.
and you need a way to increment the step you're taking. For example, let's say I want you to print numbers from 1 to 10. So it would be something like this. For initialization. Initialization, it would be, okay, so we're just talking about initialization. It would be int I equals to 0, or for I equals to 0. And it's going to complain in a second. You're going to see that. So for I starting at 0 and while I is lower or equals to 10, use this increment. It would be I++. All right? As you can see,
Okay.
it is complaining in here. Do you see the little snake under the 0 at the initialization? It is just saying, okay, you just give value to this variable, but you're not going to use it because it's going to be replaced before you're using it. That's what it's doing. Let's take a look.
Okay.
Let's see. Over in here. Okay. The assigned value is not used. Why is not used? Because you're just assigned a different value in here. Got it?
Okay.
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 So this means I don't need to initialize the variable. I just declare the variable and initialize it later. All right?
Okay.
Okay. This is one way to do it. Let's print something. So system.out.println. Let's print I. Let's print the step value. Okay. So
Okay.
going and starting at 0, it printed from 0 to 10, which means it printed 11 lines. All right.
Right.
Any questions so far?
Nope.
Okay, this is a hint for you. Every single time you're talking about a variable initialization, you're talking, actually, when you're talking about arrays or you're talking about vectors, arrays and vectors in Java, they are going to start at the 0 position. So if you want like 10 iterations, you need to go from 0 to 9. That will give you 10 iterations. All right. If you say something like go while I started at 0 and while I is lower or equals to 10, this means, okay, print this 11 times. So one way of fixing that is just saying, okay, start at 1.
Okay.
Another way of doing that would be while I is lower than 10. Because when it hits 10, it would be equal, so it won't happen. Or another way would be while I is equals to 9. Lower or equals to 9. Those are 3 different ways. The question is, what is the value you want printed in here? You want printed 9 as the last number, starting at 0 and printing 9, or do you want to start at 1 and print 10 as the last number? That's the question you need to ask yourself. Got it?
Okay. Okay.
Easy?
Yep.
Okay. All right. So now we have this this way. Let's do it again. But this time I'm gonna show you the declaration and initialization at the same loop. So, for example, for x equals to 1, while x is lower or equals to 10, x plus plus. There you go. Same thing, right? Oh no, it's complaining because you haven't declared x. All right? You can declare x in here, right inside in here. You see?
Oh.
Okay. All right. So what's the difference between those two? System.out.println x. All right. Let's see what happens. So it printed from 1 to 10, which was did by
The
here.
first one.
Okay, and then it started and printed again from 1 to 10. Okay. So what is the difference between those two approaches? The difference is, what if I need the value of I right now? System.out.println, for example, the first loop step ended whoa ended on n plus, what was the variable that controls the step on the first loop? I, you see?
I.
All right, so the first loop ended at I. All right, let's see
Okay.
if it works. The first loop ended on 11.
Because it did 0, right? No.
No, it's because you got an I++ in here, remember?
Yeah.
So it incremented at the end.
Oh, okay.
It took an extra step. I'll show you that, okay? Okay, but I want to print now the same information, but this time about the second loop. And what is the variable that controls that?
I.
No, I is for the first one.
No. Oh. X.
X.
Sorry.
Excellent. X. But as you can see, there's a problem now. What is the problem? X is not declared, you see?
Yeah.
Okay, but you did declare it in here, didn't you? You actually use it in here. So
Yeah.
why can't you use it in here?
I don't know.
It's because of the scope of the variable. On the first one, you declare it outside of your loop. You declare
Okay.
it outside of your loop. It doesn't belong to your loop. Your loop is just taking a ride with it. Okay? On the
Okay.
second one, you declared inside of the scope of your loop.
Okay, so you'd have to do it the same way as the first time.
Yep. For actually int x. There you go. But if you do that, it's going to complain because you already have two variables
Get in there.
that it could be reached by the loop. All right? And they have the same name, so you can't do that. You're going to either just use the variable or change the variable name. Okay?
Okay.
Got it?
I think so.
Okay, so let me show you one good example on that. For example, let's pretend that you want to go from 1 to 10 in here, then print 1 to 10 on the second loop, and then you want to take from where you started. Okay? And just keep going. So let's say for I equals to I, and while I is lower or equals to 20, I++. Let's see if this works. Assignment to itself. For I, no, so it needs to be something like I equals to I. Well, let's see. Let's take a wild guess in here. I starting at the same value we had before. Print whatever. Let's see. I don't see why it wouldn't work, but let's just take a wild guess in here. Let's see if it works. There you go. It worked. It's just the IDE warning you that you're using the value that you already have. And that was what we were looking for, right? So we were looking for print from 1 to 10, take a break on that loop, print from 1 to 10 on the second loop, and then go ahead and continue or resume the loop.
Okay.
Okay, so why was that possible? Because you had a variable outside of the scope of the loop.
Okay.
If you try to do the same thing with the x, saying for example that x equals to x, it's going to complain. Why is it going to complain? Because x has no value, you see?
Yeah.
Why it doesn't have value if you assign it in here before?
Because the first one, from what I'm understanding, the first one is the one that determines how it has to be.
Yeah, but the first one starts and dies at that loop. Okay, the
Okay.
scope of that variable is only accessible inside of that loop. It can't be accessed outside of it.
Oh, okay.
Got it? Any questions?
Then I don't know. Why is it complaining then?
It's complaining because at this one, it's an entirely new variable. Even though it had been declared before in here, when you
Okay.
reach this line, that variable x is gone. It doesn't exist anymore.
Okay.
So on this one, it's an entirely new variable. And you're saying, okay, take the value you had before. I had no value before.
Oh,
I
okay.
just
Okay.
started.
All
Got,
right.
got it?
Okay. Now I got it. Yep.
Okay, so you need to give some value in here. And then you can go on and do the loop. Any questions?
Not right now. I think I
Okay,
understand it.
so
Kinda.
assignment. Let's do a comment in here and assignment. Rewrite, write your last assignment using for instead of while.
Okay.
Easy enough?
Hopefully.
It will be. It will be.
We'll see.
It will be piece of cake.
Okay.
Okay. So this is what we had for today. It's just um, some really important notions between endless loops. It's important notions about the difference between step-based loop and loop that will end until the different breaking condition happens. Even if the breaking condition is close to software, even if the breaking condition is until while you have internet connection, keep streaming this. This is one way of saying that. Okay.
Okay.
Let me tell you one example. If something just say, "Hey, that was bananas." That's not how we do that. Sometimes when you are downloading a file from the internet, the first thing
Hmm.
you do while the loading is asking the other side to the other party, how big is this file? How many bytes does it have? And then
Hmm.
the other side is going to say, okay, this file has 100 bytes. All right. So in that case, you know how many bytes you need to download.
Hmm.
So it would be perfectly um, understandable. It would be okay for you to use a step loop like this one. For
Okay.
it I equals to 0 and while I is lower or equals to 99, download 1 byte, download 1 byte, download 1 byte. And that would, at the very end, would end up with 100 bytes. That's one way of doing it. The other way is send me the file until I reach a special flag that says EOIF. In case of you're wondering, EOIF stands for end of file.
Okay.
So you can download a file using either for or while. That's just a different approach of doing it. Okay, it all depends on the protocol or depends of how you're going to handle that. Any questions about
Okay.
loops?
No.
Okay, so since it's this easy, and I'm pretty sure you were not you haven't believed me at all that you would end up with such easy assignment, I want you to write a software that will print the times table from 1 to 1, well, 1 to 10. That will be easy. Just remember times table, I'm not sure if there is the same thing, but it would be 1 plus 1 times 1, this, 1 times 2,
Yep.
this, and so on. When it reaches the end, it's going to change from 1 times 1 to 2 times 1 equals 2.
Okay.
2 and 2 times 2 equals to 4, and so on. Okay, so I want you to print the times table using whiles, actually using the loop. Okay, so it's not going to be while, it's going to be for. All right,
Okay.
but in this case, and as a hint, I'm gonna drop you something in here. You will need a nested loop.
Okay.
This will be kind of tricky, okay? And just to let you know, one of the loops will run way faster than the other.
Okay.
That's a good hint, right?
I hope so.
Okay, so it's going to be nested loop, a nested loop. And as a rule of thumb, the nested one will always run faster than the other one.
Okay, these up here are all separate loops?
Yep.
Okay, so then how would I go about nesting them?
Okay, you just go inside and create another loop for.
Oh,
Okay,
okay.
just keep in
Okay.
mind that you can't use the same variable name because you're
Okay.
inside of that loop. Okay, so even if you do something like
Right.
this for int x, for example, x is still a variable that you can access, as you can see in here, right? So if you
Okay.
try to do
Yeah.
something like for int x, for int x equals 1, while 1 is lower or equals to 10, I++, for example, you would complain. Why? Because x is already declared in this scope. So you need to change that, for example, to z
Okay.
or to whatever. Okay?
Okay. All right.
Okay, now you have a loop. And let
Okay.
me erase this because this is pretty much the answer for the second assignment. So at least I'm going to make you watch the video again. At least this is something I'm going to say to make you.
Okay.
All right, Red. Any questions?
Nope, I don't think so.
Okay, great. I think this was really productive. So I'll talk to you on the next class, and good luck with your assignment.
Thank you.
Bye bye.
See you later.